Good afternoon. Thank you. So much happy to share the knowledge and expertise in this such kind of event. So that would be my topic. So a little bit on what I'm going to cover. So I'm going to cover a little bit of context, where we are with industrial IoT and IoT and OT in special when it comes to the security. So, and then I'm going to share some of my research work that I did on this field, where I am still constantly working and trying to come up with cybersecurity by design for those infrastructures. So that would be the whole. And then at the end, highlight some main points. And then whenever if you have any thoughts or any questions, save it those for at the end. So I would left some time for that part. So that's me. The whole of my background and expertise is built on technical, on hands-on. So very recently, lately, I got to at the academia. So I'm using that knowledge and that expertise that I have, giving to my students there at the Bloomsburg University, right now called Commonwealth University of Pennsylvania. So that's me. If you want to reach me over LinkedIn or at my website. I'm happy to talk and discuss and have and work together. Why not? On such kind of fields. So operation technology, industrial IoT challenges, we are all aware that most of those infrastructures deal with a lot of complexities. Why? Because we have a very diverse environment of manufacturers that they don't care so much about those security of those devices, especially sensors, and then the rest of infrastructure that support this device, this small device that would just generate data constantly. And this device would not care so much if we are able to collect those and store somewhere and treat those safely whenever those will be transmitted over the network. So we are aware of all those massive device scale that we have. A lot of protocols are around for quite a long time, and none of these, I can say that those would be updated and would be enhanced when it comes to security. You have Modbus, you have a lot of those MQTT protocols that lack a lot when it comes to the security. And then all about that vendor side, where you would have a lot of vendors that they just produce massively, and they not so much tend to focus mostly and align well that manufacture process when it comes to security. So a lot of things are happening within the EU, for example, when it comes to industrial control systems on that aspects, but I haven't seen anything that coming around here, especially in US. And what widely is very on low level. It's just initiatives that are talked so much, but no one is trying to put the focus and the light towards that alignments on whole that legal standards, frameworks, and best practice that we already have. So no need to invent something you already have there. Just stick to those from a manufacturing process from the beginning, and that would be, you would be okay. You would be safe at some level. And then later on top of those, use those emerging technology that we already have. Machine learning, AI especially, bring that creativity. Why not? I'm not saying that replacing the whole thing with an AI, but use something that is there. And I'm going to show those later on how we would be able to use those. So the focus would be on incident response when it comes to those industrial IoT infrastructure systems. So incident response is struggling so much when it comes to responding and managing and handling those incidents in such infrastructures. Why is that? Because incident response is facing mostly the teams that are working, people that are working on that kind of field, on that job, on that role, would be having a lot of those called data blind spots when it comes to the logs, where a lot of those would be not so much complete. You would have a lot of fragmentation where you would have one set of devices coming from manufacturer that is out of the way when it comes to the communication and protection and some of the functionality that those would have built in that would not treat so much well that communication and that whatever would be able to apply as a security mechanisms. And you have all those set of different manufacturers within one infrastructure, within one facility. And then at the end, where those incident response people, teams would be sitting there and monitoring and trying to handle those incidents, they don't know what to do whenever they would not find so much evidence to further investigate. So the whole idea of incident response is capture that log, and then drill down deeply and investigate further, either for security mitigation or digital forensics. But if you would be in such kind of environment, you will lack for a lot of those evidences that would be coming potentially from a device, and then from all those gateway points where we put there to collect, and then from edge points. So that would be mostly, and then we have a lot of several things that those incident response teams would just have a lot of difficulties that would come from that, the beginning, from a source point where you don't have so much evidence, logs, and metrics, and things that you would be able to further identify. What are the trends? Where is the gap that lack? Where is that deviation that from a baseline that I already have that is coming through? So threats are evolving as in techniques, in methods. Hackers, malicious actors, APT groups all around the world worldwide are doing that constantly, and you see a lot of those that I showed here to you, but the list is long. I couldn't wrap up all those within one place. And CISA, a very good entity that is working so much to expose those kind of lacks and gaps and threats and risks when it comes to industrial infrastructure. So they're doing a good job, but needs more to be done from point that we would be able to have that kind of accountability when it comes to the manufacturer, and not just on whenever we apply there, whenever those devices would be sitting on the organization infrastructure. They might do something, but when the device would lack on their design, on the firmware for security protection, you can do nothing. And then add something else on the top of that where those devices would have that limits on computational power. So you can't add so much encryption, things, algorithms on top of those devices on their end, and expect from those devices to act and behave in a normal operation. So exposure is high. You just need to go to the Showdown.io on that platform. Just search for any filter that you wanna, any port number that is used on ICS, Industrial Control Systems, Modbus, MQTT, whatever, Siemens, DNP3, and you can see a lot how much that exposure is going on when it comes to targeting those IoTs. And yeah, there are some exposed cases that has happened with all those protocols that are around that I put it here. Incident response cannot keep up the pace that what is going on. So this is the whole idea, the whole topic, my research work and objective is to bring some guide, some help, some support, some knowledge to those people that are sitting all day long on all those cybercrime units, incident response, SOC teams, CERT teams. That is a really intense job and role whenever you would be dealing and sitting on that chair and expecting for any incident that might hit you. And at your end, you can do nothing because you would lack about those metrics and evidence that I just said and logs. So let's see how this would be better and better. So why AI or machine learning, all that thing. So I'm not talking that AI would just replace humans, but let's just empower those or give some superpowers to those incident response teams whenever we can. Why not? How we would do that? So here would be the part where I'm going to share my research work that I did last year. So I was part of that team on ICT Academy, and they got a partnership with the GCA Global Cyber Alliance, and they have the initiatives, the project called Atdhe, where they put the honeypot there and they are collecting those logs from all those IoT companies, those companies that would have on their premises some kind of IoT solution. And we got that research project, and we were partnering with them for the 9 months. So we did this research from the beginning. So first, what was done, they hand over to us that data set that has that huge amount of rows when would be attacks. And we took that data set and we were trying to figure it out what we can do with that data set so we would be able to build something and to bring to applicability and not just doing that research and that's all those data analytics. So it wasn't just data analytics. that was following one of the data science lifecycle. So we follow this kind of data science lifecycle all the time. So my whole work on the research is based on this kind of roadmap when it comes to the research. So there are two phases. One phase is when you will start and understand the data. So it's all about the data analysis and understanding those data and all that context where you are. And whenever you do that, the next step, the next phase is just doing things, utilizing those technologies and emerged technologies that we have long time around machine learning algorithms. And then on top, you can just bring that creativity by having the AI. So that was the whole roadmap that we took as a structured approach when it comes to scientific approach and reproducibility. So we did that, we did those understanding, and we took those steps where we would be dealing with a lot of analysis, and we call it EDA, exploratory data analysis, a phase where you would understand what you are dealing, what kind of data. And then this was the first step where we did that, and we did some kind of analysis, and we come up with the results where we were trying to look more, which would be those username and passwords that are used the most that has successfully achieved access in a real IoT environments. That was half of data set was succeeded, and what was used, the commonly used username and passwords, was successfully breached and exploited. So that tells you a lot of things that where the security would stand, and I cannot reveal all those data when the source and everything and geography location because of that research project that was objective and maintaining that privacy of all those organizations, but those were the real data that are coming, and we saw those, how those would reveal this analysis, that behavior of those patterns of attackers reuse those. And then further, we deep dive more on the following phases where we would head towards building that machine learning model. We use some features, we use the actual data set based on that outcome of those analysis. We took some of it, and the rest we just put it out of the scope. It wasn't our objective. Our objective was building on top of that results that we got, that understanding, build a model that would be able to predict at some percentages, because you know when you build machine learning models, you can't have them to behave 100%, but there will be some behavior that I'm going to show to you. And then building on top of that, that model that would be able to predict based on this data set that was taken from a real data, specifically on IoT infrastructure coming from a real organization. And let's see how that would bring some value within the community and the industry. So as a conclusion, there are common vulnerabilities, especially in the login field, so that we're talking about the login field within the data set that are exploited multiple times. We see that 23.4 million, total data set was 56 million. So certain login credentials are common targets for attackers. That is a commonly used username and password was used there, for sure. If you want to deep dive more on this work, I'm going to share later on the link where you would be looking at the publications that we did and a lot of details that we published there. And many attack attempts do not successfully use or capture credential, of course. So those were more in details analysis where we would come up with those graphics where it would show login field that has significantly lower count when it comes indicating that not all attacks were successful, of course. And a high number of unique values emphasizing the dynamic and diverse nature of the IoT attack landscape. And then logged in field that has a frequency for the most common successful login combination, suggesting commonly exploited vulnerability. What we did, we went to the feature engineering process. As you may know, that's a process where you would decide which field would be that most important and valuable for your further developing and designing that model on the machine learning. So we selected some of them. So duration would give us that, how much long that access was around, and login indicator would have all about the username and passwords that are really used against, exploited against that infrastructure. That honeypot did a good job and they will be able to capture real, even the geographical location from where that's coming. That could be either ISP IP address or the real IP address of someone, but we would be able to know and to track that to geodistance. Command frequency, how often that attempt was happening, and credential tried, what kind of credential. So the honeypot captured that, what kind of credential, and from that field, we saw that commonly used password and usernames were used actually within all those organizations that use IoT. That speaks for itself where we are. And protocol encoding more on that. And then we use certain type of algorithms. We were testing all back and forth on those, and we decided on supervised machine learning, where we trained that whole model on top of that data set, and we came to the results where a behavior of that model was good, was the behavior showing some very high levels of accuracy and precision when it comes to effectively identify and distinguish what was a successful exploited vulnerability and was not. And then the other metrics would showing also the good results when it comes to the introducing and indicating that the model is well balanced. So all those matters when it comes to the data science, as you may know. So when you would deal with data analysis, you would have all those balanced and imbalanced data set where you would need to take care of, so you would have a good behavior model at least, and not just showing, whenever this model would be showing us 100% all the metrics, that's not something that was going correctly. So that means that probably you would have an imbalanced model where that just behaved 100%. We can't have that one. We can have around that number, but not exactly. And then further implication for IT security, so that would be able to be used as a model that would just enhance those organizations that GCA Atdhe project was capturing by their honeypots to provide them more on that enhancement when it comes to cybersecurity. So this QR code is towards those publications if you would be interested more looking on that work. So what this means for incident response, coming back to the main topic, so all those boxes would show us a lot of good things and positives when it comes to those people that would be sitting and working on those incident response teams. And since our focus and objectives was to bring some good and well-balanced and build and design model which could help them, and even a slight improvement on that way would help them. And if you wouldn't be on that kind of nature of role and responsibility, maybe you would not understand, or you would just heard about that. But I was engaged on previous project where I set up 2 CERT teams, one in academia and one in private sector. So I really know what they are struggling and what kind of issues and challenges they have when they would lack for evidence for logs. They can do nothing. So they would be on that kind of moment where leaving this on, going on, or we would do something, we would filter, what we would do. And we would just be hanging around and trying to figure it out, what we would be able to do. At the end, we would be, most decisions that would come on that moment by those teams, incident response team, would be acting on the network level. So quarantine, filter, stop, drop, or just switch to the next infrastructure. Turn on the disaster recovery. Integrating machine learning into the industrial IoT, that is possible. So we took this work on the research, not just on that thing working for that specific project, but many more where I'm heavily engaged on that. I'm trying to bring some kind of prototype when it comes to cybersecurity by design for those infrastructure. So I'm still working on that way. And I would expect from my audience, if anyone would be interested, to reach me, and I would be happy to work together. Why not do something good? So on the detection examples might be login brute force, geodistance, anomalies, common spikes, protocol misuse, sensor manipulation. This happens a lot when it comes to the tampering with those devices where you just need to have a signal. You don't need to be physically so much close and touch the device. No, you just need to have a signal. And with a drone, you can do that very easily, flying over that facility. Not drone, you can do that by walking over the fence, driving, whatever you want. Signaling, that signaling thing is very risky. So this is that kind of prototype that I'm still trying to work and come up with that device, cybersecurity by design, where it would bring a lot of architecture when it comes to the constantly anomaly detection based on machine learning, the whole thing. And this would be brought, of course, not just on premises, but on the edge infrastructures where we would have part of our facilities distributed even geographically on different places. And continuous learning, so that would be something that would be bringing. So we were thinking that this might be a lightweight thing that would fit those industrial constraints. So we're trying to figure out what would be those lightweight functionalities that we would be able to give to this, this product. Other researchers working on. So lately we got engaged on one research project working in our own, trying to bring some governance of cybersecurity when it comes to the health organizations, health infrastructure, so that too. How could AI be an example? So, and machine learning, before machine learning, that was that 10,000 hours per day that you would need to go over. If you would have a CM solution, that would be good, but even those CM solutions are using on the back end a lot of algorithms that are coming from machine learning. And after machine learning, so after you would have some kind of level of applicability when it comes to machine learning, you would have this kind of situation where the focus would be straightforward to that level of impact that could be criticality, high, medium, and not low and informational one, and not false positives as we used to know. We have a lot of those. The whole blueprint of this enhanced AI incident response could be, so SOC needs and the tools, right away to the tools, what kind of those tools you would be able to implement and use. Those mainly used tools that are used on the SOC CERT teams and cybercrime teams, and then why not enhance that towards the machine learning and AI and bring that creativity in the room. Future, so it will be here. So digital twins is one of the technologies that and ways and approach that we can use a lot of more. So we would be able to mimic exactly the real physical environment, physical world when it comes to the technology, and that could bring a lot of good things. Autonomous agents, continuous self-learning, and of course predictive maintenance. So that we want to be proactive all the time. So and with this kind of prediction of future, we are not just considering the replacement of the whole human factor. No, we would be there, we'd be around, but let's use those as a tools. Some key takeaways. So industrial IoT incident response is overwhelmed. We saw that by scale, diversity of devices, and limited visibility when it comes to the evidence and logs that we were able to collect. Machine learning would provide some enhancements. Why not? A lot of those. And you saw that our research verified that kind of feasibility very easily by using a random forest algorithm. That's a very basic one. Imagine when you would have a complexities of those models and that you would have a lot of more data than just those that we use on this research project. That could bring a lot of good cybersecurity. And of course, collaboration, that would be important, working together, all those sectors and industry, academia, private, and of course, those regulatory entities that those needs to play a much major role when it comes to this topic. So here is my contact if anyone would be interested to reach me. If you have any question now, we have some time.
Any questions? Anybody? Going once? Going twice? No questions, really? Okay. All right.
Thank you.
All right, everyone, yeah.